Suppose you borrow $50 at an interest rate of 15% per year. How much interest will you owe at the end of 1 year? This is probably the type of problem that you first were introduced to when you were learning about percentages. If you were starting with $50 and you wanted to earn an interest rate of 15% per year, we needed to multiply that by 15% written as a decimal, so multiplied by 0.15, and that would get us the amount of interest that we would owe after 1 year. So over here, 50 times 0.15 gives me an interest that I would owe of $7.50. Now, if you wanted to know how much interest you would owe at the end of 3 years based on this type of simple interest, what we would do is take our $15, figure out what 15% of that was, and then multiply that by a total of 3 different years to get the total amount owed at the end of 3 years in interest. And in this case, that would be $22.50. Sometimes what we're interested in is not just the amount of interest, but the total amount that is accumulated over that period of time, where you're trying to figure out the total amount that you'd need to pay back, which would include the interest as well as the initial amount of the borrowed money. So how would you figure that? In this case, we would figure out what our interest was. Again, if we're sticking with this $50 at 15% for 3 years, but then we'd need to add that $50 back in again. And in this case, when we add that $50 back in, we get a total amount that we'd need to pay back at the end of 3 years of $72.50. All right, so this is some examples of how we use simple interest. We do have formulas that we can use that you may have seen before, something like this. I equals PRT, or A equals P times 1 plus RT. In these cases, the I would represent just the interest if we wanted to figure out just the interest, or the A would represent the total amount accumulated over time. P is the principal. That's a nice economics term there for the starting amount of an investment. R is our interest rate. Again, it needs to be in decimal form. And T is our time, which is going to be based in years. So taking a look at another question, how can we make these a little bit more difficult? Suppose you borrow $50 at an interest rate of 15% per year, but this time we want to know how much interest will we owe at the end of 6 months. In this case, they're just asking us about the interest, so we can just use that formula of I equals P times R times T. There we go. I equals P times R times T. Our principal amount, again, is $50. Our interest rate is 0.15. But this time, when we want to figure out how much time it's given to us in months, but our interest rate is given to us in years. So it's really important, as always, that our units match. And so in this case, our 6 months we need to put in as 6 over 12 to convert back to the amount of years. You can think of that as half a year. You could use 0.5. Either way, when we take that $50, we multiply it by the 15%, and then we times that by our 6 months. We end up with just a $375 owed in interest. All right, so that's really going to be the main thing that you want to look out for when you're doing simple interest problems, is pay attention to, are they asking you about the interest? Use the formula for I. Are they asking you about the total amount that you need to put together, interest and initial? Then we use this other version of the formula. Sometimes they're not always going to be asking you for the interest or that final amount, but we can use these formulas to solve for any of the missing variables as long as we have all the other pieces of information. So for example, in this next one here, suppose your credit card company charges 18% interest on unpaid balances. If you owed $1,000 4 months ago and have been delinquent since, how much do you owe? So in this case, in order to pay back, we need to pay back not only the interest, but also the initial amount. So in this case, the formula that we want to use is that A equals P times 1 plus RT. Here, We want to know the total amount that we owe, so we're looking for that accumulated amount, that A value, and hopefully we can figure out the rest of our information here. The principal or starting value is the $1,000 that we owed. We're going to multiply that times 1 plus my rate, which in this case our interest rate is 18%. And then we want to multiply that by T. Our T is given to us as 4 months, and don't forget we need to change that 4 months into years. So 4 over 12, or 1/3, will give us our final value that we're looking for here. So the A is by itself. We just need to go through and actually do this calculation. In this case, we'll have $1,000 times 1 plus our interest rate of 0.18 times by 4/12, changing that 4 months into the years that we need. And we can get our final value, total amount owed after 4 months, being charged 18% interest per year. I will be owing a total of $1,060 on my $1,000 purchase. Keep in mind in this case that this 18% interest, it didn't tell us that it was an 18% interest per year. However, it's automatically assumed and implied to be annual or per year interest rates unless it's specifically told otherwise. As our last example here, suppose that you borrow $5,000 and pay back $5,150 6 months later. What was the simple interest rate? Okay, well in this case, we're looking for R, or our interest rate. We're still talking about a simple interest situation, so we're going to use one of these two formulas. In this case, we know the principal or starting amount that we borrow, as well as the final amount that we pay back, which is going to be both the interest and the initial amount. So we're looking again at using our formula A, oh, my color's wrong, that's okay, A equals P times 1 plus RT. In this case, our final accumulated amount is going to be $5,150. My principal is the $5,000. 1 plus my rate, well, rate is what I'm trying to figure out. And in this case, my time is that 6 months later. So I'm looking at 6 over 12, or half of a year. I'm just going to write that as 0.05 here. All right. Now in this case, now we need to go ahead and solve this equation. A couple of ways to approach it, but I'm going to write this as 5,000 times 1 plus 0.5r. I'm used to seeing that number in front of my variable. I can distribute the terms on the right-hand side. 5,000 times 1 gives me 5,000, plus 5,000 times 0.5r is going to give me 2,500r. Now I can subtract 5,000 from each side, leaving me with 150 equals 2,500r, and then divide by 2,500 on each side. Over here, when I do 150 divided by 2,500, I end up with 0.06 on the left side of the equation, and on the right side of the equation, my r is left alone. Keep in mind that the values that you get out of formulas are always the decimal form of our percentages. So in this case, an R of 0.06 would correspond with a simple interest rate of 6%. So as long as we know all but one of the pieces of information, we can solve for anything we need. We can find the interest, we can find the amount that we owe, we could find a starting value if that was an unknown piece of information, or we could calculate the interest rate just by filling in the pieces that we know and then solving for the missing variable.